Hello, so my name is Sergio Contrino. I'm working at the European Clinical Research Infrastructure Network. It's a couple of years now, based here in Paris. And I will tell you something about the interoperability, sorry for the word, in the Vaccelerate project. I will briefly introduce the project, the Vaccelerate, show you the methodology for the evaluation of the interoperability in the project, with some final remarks of the result of the analysis. And I will also have a sort of appendix about the data sharing that we are planning for the project. Before doing that, since I did very little of what you will see now, I show you the credits for the work. Mostly what has been done is done by Salma, that is actually here in the room, Salma Malik, and Gert Felder. And the other people that you see there is from the work package for data in the project. So Vaccelerate was initiated by the European Commission during the pandemic to coordinate phase 2 and phase 3 of the vaccine trial across Europe. He built a wide network for vaccine trial. I say wide because it's something like more than 400 sites. And one of the objectives of the project was also to improve interoperability, fairness, and eventually the reuse of the data produced by the project. This is a description of the various work packages of the project. As I said, the work that you see now is done in the work package for the data management. Recently, there has been an extension for evaluate pandemic preparedness in Europe. That is now done by the work package 3 and will finish in January. The project was comprising 3 multinational clinical trials, 2 based on the adult population and 1 on pediatric one. And one of the adult population was for aged people, so people older than 75 years. And the evaluation of the interoperability was done examining the relationship between the protocols, the trial protocols that have been used, the data management system, and the metadata. After that, there was an analysis of the difference that emerged, and also of the lesson learned during the application, actuation of the project. So from the point of view of this was mostly a manual work, actually, that Salma and Gert did. They compared the 3 protocols, and then the 2 adult protocol with the master template. And the same was for the metadata, a lot of manual work checking all the variables used. Since the vastity of the data dictionary, for example, there was also a focus on the core outcomes that were posed in the master protocol. From the point of view of the data management system, there was an analysis of the process of exchanging data with the data center, and that was mostly done via a survey. So there was a high level of compatibility between the different protocols, as probably one could have imagined. The main differences are due to the discriminatory point of the 3 trials. That means the demography, the age, that will, of course, bring a difference in the variable used and so on. And that's true between also the three protocols and the two other protocols. So there is a good overlapping of the data there. For the metadata, the use of standard for the clinical data acquisition that greatly improved the interoperability of the system, being using the standard one of the main technique to improve interoperability. There were non-communality, again in the CRF, but again that was mostly due to the demography, to the age of the population. One positive in the planning of the project is the decision that was made to use one single data management center that made the whole operation more homogeneous. That helped also the definition of the metadata through the three clinical trials. There were differences mostly in the coding and labeling and so on that were adjusted during the trial. Data transfer methods were common to all sites. The process was facilitated by this trial master system that produced template for this transferring of data. The system was relatively new, was built for Vaccelerate, but it worked reasonably well for the project. There were some, one of the projects was not using, was still using manual electronic data capture, and so that was for the sample, sorry, that was a point that needed to, so it was clearly a disadvantage for the system. Well, this repeat more or less what we went through, so the protocol and the metadata. Maybe it's interesting to notice the metadata with the various variables that are elencated there. And the use, again, of the standard. As you can see, there are all the labeling is standard labeling from CDISC. So the main conclusion, and again, the lesson learned from the project is the use the master protocol was increasing efficiency and data interoperability. And of course, the use of recognized data, metadata standard, improved a lot the analysis. The methodology for the analysis is illustrated in a paper that is at the moment under review, from which the title of this is a short presentation. Again, from the point of view of the improvement of interoperability, the design of the master protocol as generally as possible is important, because the protocol, again, master protocol can increase a lot the interoperability, the homogeneity of the system. The metadata that has been in that way designed for the vaccine trial is a useful resource by itself, and that's what we felt. And again, the use of standard is fundamental for interoperability, and as I mentioned before, a barcode system for the sample collection would have been a plus. One of the three trials that we considered, the one for the age, the very adult population, the one over 75 years, is piloting now the submission of their data to another tool that we developed in ECRIN, that is the Clinical Research Data Sharing Repository. That is a repository that plans to store clinical trial data for secondary use. And it was built in the context of two other European projects, Yosk Life and by COVID. And this is more or less how it works. It's a cooperation between ECRIN and the University of Oslo that has a secure data service called TSD that is commonly used in the Nordic country, but especially in Norway. More or less, the idea is that the data holder furnish all the metadata necessary to find what we call the data object connected to a study. Data object for us is more or less all type of file, like protocols, study plan, statistical analysis, and so on, and also publication. But mainly we mean the individual patient data. So there is the process of submitting to the repository, to the application, the metadata to make it findable. And also there is the process of assigning what we call, this is the example for the transfer, so from data holder to repository, to sign the agreement to transfer the data in accordance to GDPR rule. Maybe on this side, it would be nice to have some comment from all the legal people in the room. When all the legal part is done and the metadata has been submitted, the application allows the secure transmission from the data holder directly to what we call the trusted research environment, so the repository in the secure server in Norway. And then there is, of course, communication back about the result. This is just to show you what are the status of the submission for the study. We are at the data signing, the data transfer signing stage. But most of the metadata, for example, has been already submitted, as you can see these are 2 pages, one with the study data and one with all the data object, including all the data object connected to the study. I will just add that the application has also a browsing facility, so you don't need actually to log in to be able to browse through all the metadata that is in the repository. And I think that's all. Thank you.